Hello guys, welcome back to my YouTube channel, DotNet-Dev-Journey with Jacob. And today is my day 4 of my .NET developer journey to becoming a professional developer. And today we are going to be looking at the concept of OOP, and if time permits, we're also going to look at access modifiers. But I want to keep my video as short as possible today and kindly follow along. Thank you. Yesterday, we were able to speak on, we were able to do few things. We, excuse me, please. We were able to write a program that takes in the list of activities that we would like to do. That's a to-do list application. And in that application, we made use of all the things we've learned previously, the methods, the conditional statements, the loops, iteration, and the likes. But today, like I said, we are going to be looking at the concept of OOP, which is object-oriented programming, and we are going to be applying that on the same application that we built yesterday, which is the to-do list application. So, what do we mean, or what do I mean by what is OOP generally? OOP can simply be described as a programming concept or paradigm that revolves around objects and encapsulating both data and the functions that can be performed on those data together. So it involves encapsulating grouping data and the functions that can be used to manipulate those data together. So I hope we get it now. So simply put, it just means that it's a concept that deals with grouping data and the method of manipulating those data in the same container, in the same space. So here we go. For instance, uh, OOP is a programming paradigm that helps to look at real world scenarios in the terms of entities, real world objects. For example, looking at a car. A car is an object, is a real world object. And, you know, we can also say object-oriented programming is just a way of writing computer programs by thinking in terms of real life objects instead of just writing codes and instructions. So here we are going to look at the basic pillars of OOP. And the things I learned is that one of the major pillars of OOP is a class. And what does class mean? A class means a blueprint for creating an object. A blueprint for creating an object, like an instruction paper that tells a person how to make an object. For for instance, if I want to make, let's say, a toy car, or any form of toy, the class simply means that it's an instruction that gives me the way on how to, that tells me what to do and how to make a toy in order to be able to create a toy. So the instruction tells me what the toy has, which is the data, the attributes, and what the toy can do. That means the ability that the toy will have. So it tells me what the toy has and what the toy can do. So for instance, if I'm making a real car, a class tells me what the car has and what the car can do. So what the car has can simply mean speed, color, uh, what else? What else? I'm trying to think. Speed, color, what else? Okay, let's leave it at that. But because nothing is coming to my mind now. But the ability of the car, what the car can do, the car can drive, it can on, it can brake. So things like that are what the car can do. That means it can accelerate, it can decelerate. All those are the abilities of a car. And a class is what tells me what the car can do. So, yeah, that is just about class in a nutshell. And we are going to be looking at it in a moment. Okay, let me quickly give an example of that here. So let's create a class named task. So we want to add a class named task. So we are saying class task. Now, like I said in the definition, a class is an instruction paper, is like an instruction paper that tells us what an object has and what an object can do. So now, this task is going to tell us what a task will have and what a task can do. So now, for instance, a task could have, let's say, the title of a task. So we declare that's what a task has. We are starting by what a task has. String title, title, then what other thing does it class have? Okay, it has description. Sorry, I'm supposed to put an access modifier here. Say public. Then here public string description. Just follow me. We are learning together. Don't forget that. Then what other thing does it? Let me change this to later. What other thing does it task have? It has date created. You can say public dates only. Date created. You can say get. Then you can equal to, let's say, date only dot from date time, then date time dot now. So what we are saying here is the time dot now. So what we want here is directly we are just assigning um we are assigning the current date to the date of when the task was created. So this is set on creation of the task. This is just a class. We've not really created the object. This is just telling us what the task has and what the task can do. I hope that is understood. So here we can say, what can a task do? I think a task does nothing if I'm correct. But let's leave it at this. Let's go to a car. Let's create another class for a car. Let's assume we are working with a car. Let's add a new class, new item. Then we say car. So here we can say public string uh, type of car. Could be an SUV. It could be a salon. So we can say string color. We can also say public string speed. Then what else does a car have? We can say manufacture date, public date only. That's if we just want to get the date without the time. So if we need both the date and time, then we can use date time. So we use date only, manufacture dates, manufacture date, and here we have it. So we can say, what does a car do? These are the things that the car has. All these are what the car has, the data. So now, what does a car do? That's the ability of the car. The car can drive. So we can say public void drive. So here, this is like a method now, a function that the car can perform. So, or let's put public accelerate. Let's use accelerate. Or let's use drive. You have to be able to drive the car, or start the car. So let's just put something like this. The car is moving. Then we can also say public void on on or whatever I want to use. Uh, we can say same thing. The car is honking. So this is just like a simple example just to let us know what a class is. As we can see, it contains the data and the functions that can be. So, okay, there's a correction to be made here. We cannot set the dates. We can only uh, get the dates. And I'll explain what this means. So we have dates only. That's from date time. Then open brackets dates time dot now. So this is just to take the current dates as at when the car was created, or yeah. And another thing here is, okay, let's make this more easier. This is thing from chapter 14. It makes this easier. We can just declare string type. These are the parameters that will be passed in when creating uh, a car object. So we have string type, we have string color. We also have string speed. Should speed be string or floats? Speed 30 miles per hour. String be should speed be okay, let's keep it at floats or integer, for instance. I'm just saying, I'm not sure right now, but just for the practice. String color, then we have int speed. Okay, so we can do this from C# 14. But if we don't want to use this method, we can use another method. But this is perfect because this is the latest version of C# and it helps us to do things more easily. So here we have it. And this is a class. It has data and it also has method like functions. So like I said earlier, that a class of a car, it has what the car has and what the car can do. So here are what the car can do, and here is what the car has. So from here, we move to object. What is a object? A object simply is an instance of a class. So class is an instruction book that tells us how to make an object. It tells us what the object has and what the object can do. But the object now is now the proper instance of that class, is the outcome of the instruction we have received from the class. So here we go. Let's create an object and see how that works. So we can come to the program here, and I'm going to comment this out. Going to comment this out. Okay, down to this place. So to comment, we are doing Control K, Control C to comment it out. So don't forget we have a class called car. So to create a car object, we can see how we can create even multiple cars just from that single class of a car. So let's say we want to create a new car. We can say car, first car. Don't forget we are using camel case for variable names. First car equals to new. That means we are creating a new instance of the car class. New car, then we open and close the brackets, and inside it we are passing our argument. So what is as you can see here is highlighted, the type of the car, the color of the car, the speed. These are the arguments we are going to be passing in, and the first is type. So what is the type of the car, which is a string, and don't forget, string is always in double quotes. So the type, let's say, is a salon car. Then the color also is string, so it has to be in double quotes. The color, let's say blue. Then the speed is integer, so we can put that in any quotes. The speed, let's say 40 or 50, thereabouts. Can also create the second car if we want to, just from that class of car. So we are saying a second car was new car, then Let's say this is SUV, then color, let's say gray, then probably this is 120, the speed. So here we have it. We have two cars created from this car class here. And here, let's access the uh, the data of the car. Let's access the color, the speed, the type. So we can say from here that first car, okay, let's use control this. I'm trying to use string interpolation here. Color of first car. We can say first car dot color. So let's run this and see what the outputs will be. So here we have color of first car, but there is no output here. It's not giving us the color of the first car. Okay, so why do we have that? First car dot color. Color of first car dot color. Trying to see why you're not getting any output for that. Oh, okay. That is because in our class, I did not assign those values to the fields here. So we can say this is equal to type, and here equal to color. So that means we are passing the argument gotten into the fields, and the field of the car is type, color, and speed. So that's why we are not getting the outputs. I hope you guys are following, going with me. So now let's rerun our program and see if this will correct the error. Yes, we can see color of first car equals to blue. And this happened because I didn't assign the arguments, the value gotten into the fields. That's why we didn't have any output here. So let's go back to our code. And from here, we can also do the same thing for the second car. Say copy, or let's make it more simple. Let's say details of first car and details of second car of second car. So here we can say color Then we can say speed. First car dot speed. I think the first one is type. So let's go back to this place and say type. So the type is first class dot type. So let's just copy all this. Okay, literally type second class type. So I'm just going to copy this to make our work faster. Then we have a color. So just change this to color. Then we have speed. Then we just change this to speed. So let's output this. Okay, let me give it space in between. Trying to use the CW shortcut. It's not okay. Don't know why. So yeah, let's run the code and see what the output is going to be. So as you can see here, we have details of first car, the type, which is salon, the color blue, speed 50. Details of the second car, type SUV, color gray, speed 120. So it's as simple as that. Now we understand what a car means and what an object means. Here is the object. First car is an object of the car class. Second car is also an object of the car class. So we can have multiple cars from that same, like multiple object of cars from the car class. Now we move forward to the uh, the pillars, four pillars of OOP, four pillars of OOP. So here we start with encapsulation. So what does encapsulation mean? Encapsulation just simply means a way of keeping or protecting our data. The way one protects a data. So you make something kind of private that you don't allow everyone to have access to them directly. I give you an instance. If you have a wire, like a cable, an electric cable, there is um, a kind of coil inside, like an iron coil inside, that carries the electricity current, the electric current rather, but it is covered with an insulator, a rubber insulator. So we cannot have access directly to the iron or um, copper cable inside that wire, but we can only touch the cover on the outside, which is the insulator. So in a nutshell, Encapsulation just simply means a way of hiding our data so that it is only through methods that we can have access to those data. We don't allow, okay, I give an example, a real life example for a bank account. A bank account is the class, for instance, and the bank account has balance. So how does encapsulation come into this? Encapsulation helps to hide the data of the balance so that one cannot just directly change his or her balance. So for you to change your balance, you have to go through a method. It's either you deposit or you withdraw. That is the only way the balance can be changed, can be modified. But if we make the balance public to everyone, that means you can just write whatever balance you want to without withdrawing or without depositing, which is a wrong way of doing things. And we know what result we'll get from that. So encapsulation helps us to hide our data and only provide a means of accessing those data through methods, through safe methods. That is what encapsulation is all about. Okay. So right here, I'm going to give us an example. Let's also create another class. Say, for instance, we have a bank account class. So let's name this bank account. So, and in this bank account class, we have uh, string, public string, account number, and we have, let's say we have account name, and we have decimal balance, public decimal balance. So we can set this, we can make this to get, then here will be private because we are hiding it, private set. I hope that makes sense. Here we are making sure that it cannot be changed. And ideally for an account number, you can't change an account number. So we can just set this to get. So which means once the account number is generated, it cannot be changed. It cannot be modified. Here we can leave this to get set, but this has to also be like a private set so that people don't just change their names whenever they feel like, because an account name is always related to, is linked to the customer's name. So now to be able to access this balance, we can now create a, okay, let me show you what this is, for instance. It's just an example. So let's go here with the parameter. Let's pass in the parameter. So we have string accounts name. We have string accounts. Oh, this should be account number, account name, account number, account name, and amount. Or we can leave that. So here we can now pass in. Okay, let's do this first. So let's go to our program and let's comment all of this out. Okay, let's see. And yeah, it's a bank account. We can also use a variable uh, first account or account one, account one, okay, account one equal to name. I think we should be able to do something like this. I'm not sure, but let's try it. The first one is account number. So let's say 0223444. That's 6. Then we have 56. That's 8 digits. Then we have name. So let's say John Smith. Name is also a string, so we have to wrap it around the quote. John Smith, which will be the account name. Then we also have, I think that's all we have in the parameter. Yes. So here we have to say bank account. So say variable account one equals to new bank account. That's if we don't want to write the full bank account here. So what it just does, it infer whatever the type is from here, and then uh, accords it to the variable name we have here and ties it to the variable name we have here. So here we can see that bank account one. So here, let's see if we'll be able to access the balance directly. Let's say console.writeLine print account one dot balance, and let's see if we will be able to do that. The balance. Oh, okay, we're able to access it, but can we modify it? Let's now try to modify it and see if that will work. So here we say account one dot balance equal to £100, for instance. We can see we have a squiggly red line, which means that there's an error. So now let's look, what is this error about? It's saying account one is not null here. The property or index or bank account or balance cannot be used in this context because the set accessor is inaccessible. Do we understand now? So we can't set it directly because we have used uh, the encapsulation concept or the encapsulation uh, idea to set our balance as private. We are keeping it private. We have used the concept of encapsulation to hide the balance data so that it can be modified. And for us to be able to set our balance, just like I explained in a bank account, you have to only deposit or withdraw. Without depositing or withdraw, your balance cannot be affected. It cannot be modified. And now, I guess we understand, we are clear on that. So to be able to have access to this balance, now let's create what the bank account can do. This is what the bank account has. But now what can a bank account do? A bank account can deposit, can withdraw. So let's go public void deposits. So we have to pass in a parameter because we have to be able uh, to get an amount that we want to deposit. So here we are saying decimal amount. Our balance will be affected by the amount we are going to be depositing. So, but now no one comes to the bank and deposits a negative value or a zero value. That doesn't make sense. So we have to be able to control what the customer is going to deposit, and we have to check the amount first if it is a negative or a zero value. So to do that, we say if amount is less or equal to zero, or we can just say if amount is less than one, or peradventure we want to set a limit to which the limit to of the amount to which a customer can deposit. We might want to set it to the limit of 100. That once a customer wants to deposit, it has to be from 100 above. But let's just leave it at this. So we can say return. That means it's not going to work. Or probably we can just do, uh, let's say we do console.writeLine, but this is just for practice. So we say console.writeLine cannot take, cannot deposit an amount. Let's okay, or enter an amount greater than zero. Enter an amount greater than zero. So, and if this passes, then we say balance. So we say balance plus equal amount, and then we end it. So now let's go back to our program and use this method to deposit into our account. So let's say account one dot deposit, and we pass in an amount. Let's say we pass in -2. Let's comment this out. Okay. Let's still write our balance and see if it is going to be affected. As you can see here, we have enter an amount greater than zero, but it still went ahead to do this, to add this -2. So what we can do, let's control the flow of our program. Let's wrap this into a curly bracket. Let's bring this here. So instead of proceeding to the next line, let's just return. So returning means that we are breaking out of this code, this block of code from here. So if this is the case, then break out. So which means we are not going to come into this at all. So let's save and let's run our program and see if it's going to display the balance. You can see enter an amount greater than zero, and the output of our balance still remains zero. So it means the -2 does not affect it at all because it did not allow the program get to this line of code. It just broke out from here because the amount we passed in was less than zero. So now let's enter a proper amount, and let's rerun the code. So we can see our balance is now 100. So here we've achieved what encapsulation is all about. So now the next thing we are going to look at is inheritance. Inheritance simply means inheriting features from the parent class. So it's just like when children inherit from their parents. So a child could inherit a property from the parents, could inherit a car from the parents, whatever, could inherit anything from the parents. So how does a child get to form the eye, the nose from the mouth? So a child is just uh, another form of what the parent is. So we know a dog will only give birth to a dog, a lion will only give birth to a lion. So in this context, we are saying that the parent class has been defined, then a child class can inherit from that parent class. I give an example. We can have a class called a person, and we know a person has a name. A person will have age, will have, let's say, race, or yeah, could have, I think, the basic information, name, age, sex. And we can now have another class called students, or let's say staff. Or we can have a class called vehicle. A vehicle we have speed, a vehicle we have color, a vehicle we have maybe type, and from that vehicle we can have a car. From that car we can have a bus. From that vehicle we can have a bus. From that vehicle we can have a truck, which is also a vehicle. So all these are subclasses of a vehicle. So we can say a car is a child class of a vehicle class. I hope that makes sense. So for example, let's create a class now, and let's rename this class. I don't want to create a lot of, okay, let me just add another file to this, and let's say this is a animal class. Animal class. So here, an animal, what does an animal does? An animal could eat, an animal could make noise. So let's say we have this animal here, and public make noise, public void make noise. So, and here we say, uh, what can we say here, for example? Or let's say eat. Let's say eat, okay? Because all animals eat. So let's say eat. All animals also make noise, but their noises are different. I think a cat meows, uh, a dog barks, a cow moves. So those are the different sounds they have, but we are coming to that. So let's just say eat, and say I am eating. I am eating. So now we can have another class that inherits from this class. So, and for a class to inherit from another class, let's create another class here. Let's add a new item and call this a dog class. So a dog class, to inherit from the animal class, all we need to do is just put uh, this semicolon and a colon rather, a colon, and then we put refer to the animal class here. Then automatically this dog inherits this its method from the animal class. And let's say public, dog barks, say public void back. I have to put this because it's a method. Then we say I am a dog and I am barking. So let's go to our code, our program, main method, and I'm commenting this out, Ctrl K, Ctrl C. Now let's create a new animal object. So here, how do we do that? We can say animal. Does that work? Let's try that and see if that works. Equals new dog. Don't know if this will work. I'm just trying it. So I'm playing around the code as well. Oh, oof, it works. So it's saying we are creating a dog, but the dog is an animal because the parent is an animal. We can also say dog animal, which will work as well. But I just want to use the parent class animal. So here, so see that this dog, okay, or let me say animal dog, let's just use dog, equals to new dog. So now to know and see if this dog really inherits from the animal class, because in the animal class we have this method, its method, and in the dog class we have this back method. But I said once this dog class inherits from this animal class, automatically it also inherits all the methods that comes with the parent class, which is the animal class. So here, let's see how that works. Let's remove all this. I said dog, sorry, dog dot eat. We can see is able to access this. And let's also say, okay, dog dot back. Oh, it's not accessing the back, it's only accessing the eat here. So let me change this to dog and let's see if that will pop up dot back. Oh, okay. Now you see we are learning as well on the go. When we used animal, it's only seeing this dog as an animal, so it's only showing or displaying the method eats because it's seeing this dog as just as an animal. But when we use dog, because dog has inherited from the animal class. So it can also, see both the method in the animal class and the method in the dog class directly. So here, the dog is inheriting it from the animal class, from this animal class, and it also has its own method, which is the back. So now let's run this code and see what happens. Here we can see I am eating from the parent class animal, and here from the dog class itself, I am a dog and I am barking. So that's what inheritance is all about. So quickly, let's look at polymorphism. What is polymorphism? Polymorphism is having one method or one name or one word with many meanings. One word with many meanings. So we can declare a method, and then that method can have different implementations, different functions for the same word. So we can see, just like I said earlier, that an animal can make a sound, but making a sound is specific to different animals. Making a sound is unique in its behavior, in its functions to different animals. I said a dog barks, a cat meows, a cow moves, but all of these are animals, but they make sounds, but their sounds are different. So make sound can have different functions, implementations for different animals. That is what polymorphism is all about. So here, how do we do that? Let's go back to our animal class and let's say public virtual make sound. I know you're wondering why are we using virtual? Virtual here simply is saying this method can be overridden in the child classes. It can be overridden to implement to a different implementation that is unique to the child class. That is why we are using virtual. If we do not use this virtual, then we won't be able to override it. So public virtual void make sound. And what does make sound do? Let's say generally, I make sound. So here is the method, but we can override this method in the dog class. We can say public override void make sound. So here we can say console.writeLine I. Okay, let's just copy this from here. We put it here. Let's put this at introduce. So we can leave this at I am a dog. So make sound I am a dog and I bark and I bark. So we can also have another class of, let's say, a cow. So a cow also inherits from animal, and it also implements the method makeSound. So it's going to override public override void makeSound. So, and here I am a cow and I move. Okay, let's say I am moving. Then let's do for the dog. Let's just copy this. Okay, I am. Let's change this to I am backing. The reason why I'm removing I am a dog is because we already have the introduced method that says I am a dog. So I'm copying this to the cow and introduce I am a cow. So now we have two classes that are inheriting from the animal class. The cow class, which is a child class, inheriting from the animal parent class. The dog class, inheriting from the animal parent class. And here's the polymorphism. In the animal class, we have this mix sound. And in the inheriting class, the primary, the child class, we can see that this is the same make sound method, but now we have overridden it to implement it in a different way. But in the animal class, all it says is I make sound. But in the cow class, the make sound says I am moving. In the dog class, it is the same make sound is saying I am backing. So let's see how that works here. So dog, new dog. So let's say dog dot introduce of introduce and dog. Okay, yeah. And let's say dog dot make sound. So here we do cow dot introduce let's save this. Oh, sorry, I've not created um the cow object. So new cow that's introduce introduce. Why it does not contain definition for introduce? It does. Only for introduce, yeah. Oh, sorry, it's intro. Should be intro. Let me change that. I didn't spell it correctly. See, we have to be conscious of how we spell things so that we don't run into an unnecessary error. So it should be introduce, not introduce. Because I was wondering where is the error coming from. So we have cow that's introduce. Meet cow. Oh. Should be cow. That makes sound. So now here we go. Let's run the code. So the first one, dog, I am a dog, I am barking. I am a cow, it's supposed to be I am moving. That's a spelling error. I am moving. But we can see how it functions and how it works. So the same method name but different behavior. The next one is abstraction. What does abstraction means? Abstraction only show what is needed. It only shows what is needed. This video is becoming long. I'm going to speed up so that we can wrap up now. So, for instance, a baby does not care how a milk is made. What they are concerned about is how to drink the milk. So whatever you put in the milk, whatever you mix in it, they don't care. But they only care about how to drink the milk. So we can also use the example of a car. A car user does not necessarily need to know the components in the car, in the engine, how the engine works, the what happens behind the scene. But all they are concerned about is to drive the car. All they are concerned about is to steer the wheel, to match the brake, to move the car. But whatever happens behind the scene in the engine, the mechanics or mechanism behind that, they don't care. So that's what abstraction means. Abstraction means only revealing the details that are necessary to the user while hiding the complex details. So we are going to look at how this works as well. Though we might want to think it's similar to um, the encapsulation, but it's not. Encapsulation controls, hides, or protects data and controls access to the data. But abstraction here, it hides the complex details of how a thing functions and reveals those things that are necessary to the open. So if you go to a kitchen, for instance, you don't care how the menu is being made, how it is being prepared. But all you see on the outside is the name of the menu. And you say, oh, I want this. And they just serve it to you. But what has been done internally in the kitchen, inside the kitchen, we are not aware of that. How they made it, we are not aware. We just know it has been prepared and is brought forward to us to eat. And we just satisfy our our desire and we eat it, our appetite rather. So now let's see how this is being implemented. Here we are going to be working with the animal class. So here we have the virtual void make sound. But there's something else we can add to this. We can then say for an abstract class, we can change this. We can say abstracts because we are trying to achieve abstraction here. So an abstract class can have a directly implemented method or function, and then can also have like a contract method. A contract method simply means that it is not going to implement the method, but the child class that will be inheriting from it will be the one to now implement that method. Does that make sense? So, okay, let's go back to this. We can use this mixed mode, for instance. We can say, make this abstract. So, for I want us to know the difference between this abstract and this virtual. This virtual means that it can be overridden, but it has implemented it, but it can be overridden in the child class. But for abstract, abstract cannot be implemented at all. So we have to remove all this from it. So this is what an abstract will be. So it means that it is only the child class that can implement this. But this abstract method can only be in an abstract class and is also to let the child class know that, oh, this is a contract. You need to promise that you will do this. So the child is promising the parent class that I will make sound. I don't know if you understand. So it's like a promise, a contract which the child needs to implement. And the dog here has implemented it. Here we can see it has implemented the make sound, and the cow likewise has implemented the make sound. So now let's go back to our program and see if that works. And if we are still going to get, yeah, we can say I am a dog, I am barking. I am a cow, I am mooing. So that's just what uh, the abstraction is all about. And quickly, I'm just going to, mention this on the go. So I'm not going to dwell on this. Yeah, we are going to be looking at access modifiers. What does access modifier mean? Is like protection type, a protection level that is given to our data or our method. Yeah. So the first one I'm going to look at, or I will simply say an access modifier is like a control to the extent to which something can be accessed or seen. That is, who can see or use something. So we start by describing what public is. Public is an access modifier, and public just simply means anyone can have access to it. Anyone can have access to it. So a public uh, field, a public method can, or a public class, let me put it that way, can be accessed within the same class. A public method can be accessed within other classes and within other projects. So public means anyone, anything can have access to it. It can be accessed in the same class where it is being declared. It can be accessed even in other classes. It can be accessed in other projects or assembly. Then we move to private. Private means that it's like a secret that is kept to yourself. You are the only one that knows the secret. No one else knows it. So it's like a secret, and it is kept private just only to be used inside the same class, only inside the same class, which it has been declared. So if we declare, like we declared the balance in the account, in the bank account, we declare it to private sets. Private sets means that no one else can set it. It can only be accessed from the class and through the method of the class. So it is only within the context of the class that it can be accessed. It cannot be accessed outside the class bank account. So we move to protected. What does protected means? Protected means that it's also a level of protection given to data, and it means it can only be accessed by family members. For example, we use the issue of inheritance, like cow inheriting the animal class, dog inheriting from the animal class as well. So it can only be accessed by family members. If we have declared something as protected in the animal class, the dog can have access to it, the cow can have access to it because they are inheriting from the animal class, and that makes them a family. So it can be accessed from the same class and also a child class, which is, it revolves around the family. And we also have the internal. Internal means being accessed within the same house, within the same compound. So it's like an assembly within the same project. So now, if I'm declaring anything as protected, sorry, as internal rather, it can be accessed within this project named this assembly named day3. So I'll give you an instance here. Here we can see internal. It means it can be accessed anywhere within this day3 assembly. We can call for it anywhere. So here we also have the protected internal family. So the protected internal family means that uh, it can be accessed only by the family or the people in the same house. So it can be, we said protected can only be accessed by family, but now we are combining both protected and internal. So it means, and we know that internal works only within the assembly, within the project. So protected internal means that it can be accessed within a family or within the assembly, the project itself. So we move down to private protected. It's also an access modifier. And here we know what private means. Private means only accessed within the same class. And protected means that accessed within by family members. And now we are combining both together. So here we are saying private protected means it can only be accessed only by family and in the same house. Only family and in the same house. That makes sense. So it's just to control access to, what we are doing to our classes or to our data. I would have loved to work on this, uh, the task, that is the to-do list with us by applying all of this, applying the OOP concept. But there's a simple project that I developed here, student system. So what this does is just it takes in the name of the students, the score of the students, and it calculates the average. It calculate the mean score, the minimum score, the maximum score, and the number of people that passed. And here we can see I used a class called students here. So, and in the class, the parameters are name and score. And we can see the name set to the name. The score cannot be modified. So it can just be, once it's set, it's set. And the bool has passed. Here it's based on the score, which is straight out equal to 50. Then for every class, a class in .NET or C Sharp has an inbuilt to string method, which has to be overridden whenever we want to make use of the to string method. So here we also have a student manager that controls what can be done, the operations that can be performed, and this helps us to add students to a list, to remove students from a list, to search a student in the list, to calculate average, highest score, lowest score, count pass, print list, and yeah, that's it. So we have that here, and we also have the helper method that helps to take input from the user. It helps to get the student name, helps to get the student score, and helps to print the item list. It also helps to display the menu options like we see here. And here is the main program itself. And here I also use do while loop. So to run the application until the user clicks on exit or selects exit. And once the user chooses the option of exit, the application comes to an halt and it comes to a close. So this brings me to the end of day 4 journey to becoming a professional .NET developer. Thank you for joining. And yeah, I would like to take your thoughts. What are your thoughts? What are your questions? What are your contributions? You can put that down in the comment section. And I want you to click like and subscribe button to ensure that you get, the daily updates of the videos that I drop on this journey to becoming a .NET developer. Thank you guys. See you in the next video. Bye bye.